Hello everybody. I'm hopefully going to do a couple of videos so they're not ginormous when you need to go see them. I figured I'd start right with the Algebra Basics for those of you that need it. If you don't need to watch this one, you can always skip this video and go right on to the next one. So the first thing I looked at was some of us don't even know what a term is. So when you see a question asking you about combined like terms, you're probably like, what? So I figured I'd specify that for you. And basically it's a piece of an equation or expression, usually separated by a plus or minus sign. Now the difference would be in a fraction, it can be separated by that fraction line. And so the thing is, here's an example of 3e plus 7. That's two terms because you're looking at either different variables or a variable versus a number by itself, or looking at variables that have different exponents. And when I get to use my fancy colors, which I do, I can circle this. And I know some of you in the last meet had asked about those plus minus signs. Well, technically that plus sign goes with the 7. So if there's a plus or minus sign in front of it, even though it's adding subtracting, it's still collected with the number. This is an example of just one term because it has a coefficient and a variable. Because a coefficient is that number that is in front of the variable and it's telling you how many of the variable you have. The variable is an unknown quantity. So that's why they call it a variable, because it can vary, and it's represented with a letter or a symbol. This one, you see there's the letter C, the letter Y, and the letter X. So you can't combine letters that are not the same because it won't work, because it's kind of like doing the apples oranges thing. Not going to work out. So 8C plus 7Y plus 3X, that's actually three different terms. So the 8C is assumed to have a plus sign in front of it because there's nothing there. So if nothing's there, it's assumed it's a positive. That's a positive 7y, and this is a positive 3x. So in total, you have the three terms. Here, you've got an exponent thrown in here, because a lot of people would assume, because these are both x's, you can put them together. But the problem is you can't, because this is 3x squared, this is 3x, and that's subtract 5. So the thing is, you have to look at what the variable number is, because only the same variable number can go together. And if you think about why that works, I'm going to dig into my little bag. If any of you remember algae tiles, x squared tiles are those big squares that we had. The x tiles themselves were the ones that were just the little rectangles. They were the same length, but they were only a rectangle. And if you remember, not that we're going to do them a whole lot right now, the little pips are just those little red ones. So just keep that in your mind. So looking at this, you've got 3x squared as one term. You've got 3x as another term. And then you have a negative 5 or subtract 5 as its own term. So none of those terms can be combined together because none of them are like. Now, when you get down here, 3x plus 5x, those are two terms, but they're like terms because they both have an x. So when you combine them together, boom, you get 8x. Because you just end up, you add or subtract the coefficients or the numbers in front. The variable stays the same. Because a lot of people, the pitfall they would fall into is they would write this out as 8xx. But you only have to write the x once. So that explained variables, that explained terms, sort of explained the like terms idea from here. So remember, coefficients are the number in front of a variable. The variable is the letter, and it's the unknown quantity. And what I'm going to do is, this was showing you how to simplify them. So you just add or subtract the coefficients in front, and then you just leave the variable as is. There's a couple other types of questions you might see So I'm going to just erase this for a second. Because I want to make sure we're all clear on what an expression is versus an equation. So an expression is where you do not have an equal sign. So it's a group of terms, but they're not going to actually equal anything. So the only thing you can do with an expression is simplify it. You can't actually solve for it. You could also evaluate it, and that would be fine, and we'll talk about that in a minute. So this would be like 3x plus 16. And that itself is just an expression, because you'll notice there's nothing telling you what that equals. So there's no way to solve for the x. Whereas an equation might be that, because now you have that expression equaling a value. So potentially you could go through and you could solve for that variable x. So this is an equation. It's got to have the equal sign because it's showing you two sides, whereas an expression is just sort of one piece out of an equation. Now, I'm going to erase a little bit here, and I'm going to show you. If I have that expression, and we'll erase that too. If I want to evaluate this, I'm saying if x equals 2. So I'm being told what value to use for the variable. What I'm going to do is I'm going to go in and I'm going to substitute that 2 where I see x. So it's going to be 3, and then I write in the number 2 where that x would be, and I write it in brackets as a good practice. And then what I'm going to do is I'm going to follow BEDMAS, and I'm going to reduce that down to just one number, or at least to as few terms as possible. So this is going to be 6, because 3 times 2, or 3 groups of 2, plus 16, which gives me 22. So what I've done is I've taken this expression, I've substituted in the value for x that we were given. So it's not like it just came out of the air. You'd be given that in a question. And then you would substitute that in for x, and you would find this. Now, next week when we get into doing tables of values, this is going to come up again. And we'll talk about this a little further. So that's evaluating. If I look at solving, that's where I'm given 3x plus 2 equals, well, you know what? I'm even going to make it simpler than that. I'm going to make it a one step. So this is 18. So 3x equals 18. So solving is where I'm finding the value of x. And what I need to remember with that is the opposite of BEDMAS is going to apply, because you're working backwards. So really what you're doing is you're starting on this end with adding and subtracting, and then you're dealing with the multiplying, dividing, and then the exponents in the brackets, depending on the situation. The other thing you've got to remember is what you do to one side, you must do to the other. And the reason for that is if I do something to one side, but I don't do it to the other, what I'm doing is I'm creating an imbalance, because really that equal sign is like telling you you have a scale. And if you do something to this side, but not this side, all of a sudden it's either going to go down and this is going to be stuck up like a teeter-totter, or the reverse. And you don't want that to happen. So you need to maintain the balance, the equilibrium. So looking at this, I need to look at what's the opposite operation to multiplication. And if we stop and think, the opposites we know are adding and subtracting, multiplying and dividing, and in some cases you might have to remember squaring a number and square rooting are opposites too. In this case, we've got 3 multiplied by x, So I need to divide by 3 on both sides. I cancel those out because 3 divided by 3 is actually 1. And we don't bother to write 1x. That's one of those things that we accept, is if you have an x, it's assumed it's 1. And if you stop and think about it, we don't say, I have an apple, or I have an 1 apple. We say we have an apple. So we skip the 1 when it's just a single of something. So in this case, this becomes x, this becomes 6. And what I have done there is I've solved for my x. Now, you can go back and you can check by doing the evaluating and the substituting, and you can see, did that actually work? So I would test it out by saying, if I multiply 3 by that 6, will it give me the 18? And the answer is yes. So that does equal 18. The other thing you can do is something that we call the cover-up method. So if I give you x plus 5 equals 12, what I can do is I can cover up the term that has the variable, and I can say, what do I have to add to 5 to get 12? And the answer to that is 7. So I know that 7 plus 5 equals 12. So in that case, I just figured out that x equals 7. So that's one thing you can do if you're having a hard time doing the whole manipulation of this. And I can show you as well if you had it in a little more complicated form. So, for instance, if I had 2x plus 5, and I have it equals 11. Okay. Again, I can cover up that whole term that has the x, and I can say, what would I add to 5 to get 11? And the answer is, I would add 6. So what I know now is that 2x has to equal 6, because this is going to be 6 in here, this whole piece. And so then I look at this and I cover up the x and I say, what would I multiply by 2 to get 6? And the answer is, I would multiply 3. So if I go back and test the theory and I do it out, 2 times 3 is 6. 6 plus 5 equals 11. Now if I was doing that out without the cover-up method, I'd be looking at the SAMDEB. I've got to deal with that adding first. So I'm going to subtract 5 from both sides. These cancel out because, again, 5 subtract 5 is going to be 0. And I don't need to bother writing plus 0 on the end. So these actually go away. I'm left with 2x equals 6. And so now I'm going to have to divide to cancel that multiplication. And I've got to do it to both sides. And I'm left with x equals 3. And so notice I ended up at the same spot, just 2 different ways to get there. And again, whichever way works better for you, I'm okay with, because you've got to figure out a way that will help you get to the solving. Thinking about the basics, I feel like I have covered everything I wanted to for my basics video. So I'm going to end with it there. There's going to be some practice provided from the textbook that you can follow up with this. And hopefully I will see you in my next video when I do a little bit more. Okay, thanks. Bye.